Dear students, in today's class, we'll see the Gaussian distribution. What is Gaussian distribution? Which is also called a normal distribution. Gaussian distribution, which is same as normal distribution, which is similar to normal distribution. Okay. The probability density function PDF, which shortly we call as PDF, for a Gaussian random variable is given by probability density function for a random variable for a probability density function which is fx of x which is equals to 1 by sigma into root 2 pi into e power minus x minus m whole square divided by 2 into sigma square. Fx of x, which is 1 by sigma into root of 2 pi into e power minus x minus m whole square divided by 2 into sigma square. Here sigma square is a variance and variance of the random variable, and m is the mean value of random variable. M is the mean value. Okay, it is a the bell-shaped curve. The Gaussian distribution curve is bell-shaped curve, and 1 by this is upper limit, the bell shape up to 1 by sigma into root 2 pi. This is the central that mean value is x is equal to m. Okay, the complete probability is always 1. The maximum probability is always 1. Therefore, here if this line gives mean value, then the left side we remaining with 0.5 and right side we are remaining with 0.5. By combining both, we get 1. The maximum probability is 1. This is bell-shaped curve. Okay, this is Gaussian distribution. Okay, properties of this is the Gaussian probability density function plot is symmetrical. Even symmetry about mean value x is equal to m. This is also media, also the median and mode, the distribution mode of the distribution. Here in the Gaussian distribution, mean, median, mode also same. They are saying fx of x, fx of m minus sigma, which is equal to fx of m plus sigma. Mean, median, mode are equal. Okay. Property 2. The peak of the Gaussian probability density function is at the mean value is at x is equal to, here mean value is m. So we can calculate this peak value x equals m, that is fx of x 1, which is equal to 1 by sigma into root 2 pi by the mean value x is equal to. Property 2. And property 3, the area under the Gaussian PDF curve below and above the mean value is 1 by 2. The area under the Gaussian PDF curve below and above the mean value, this is below, this is left, under the 1 by 2 is nothing but 0.5, and above the mean value is 0.5. Therefore, here the property says below and above the mean value is 1 by 2. Probability of x less than or equal to m, which is equal to probability of x greater than or equal to m, which is nothing but of 1 by 2. The area under the curve is 1. Total area is 1. The total area of the curve is 1. The maximum probability is 1. Therefore, the minus infinity, if x is some mean value, if suppose x is some mean value, then minus infinity to x gives 0.5, which is nothing but 1 by 2, which is same as the property says. X to infinity 0.5. Therefore, the total area is 1. Property 4. For the Gaussian distribution plot, it's a first derivative and positive for its first derivative is positive for x less than m. X less than m are equal to 0. Positive are equal to 0 at x is equal to m, and negative for x greater than m. X greater than m, the derivative of is negative. Okay. for x less than 1, the derivative is positive. For x greater than m, is negative. Okay. Area based a question. Z equals x minus mu by sigma, where mu is mean and sigma is standard deviation, x is required value, z is value which represents area. Z is not the area. Okay, z is value which represents area, static value. Okay, problems on Gaussian distribution. Okay, the random variable z is normalized Gaussian, that is its mean is 0. Normalized Gaussian means its mean is 0 and its variance is 1. A random variable z is normalized Gaussian means its mean is 0 and variance is 1. Find the probability of 0.505 less than z less than 1.456. The solution is, given z is normalized Gaussian, which means mu is 0 and variance is denoted as sigma square with respect to random variable capital X, which is 1, and fx of x, we already know that what is the PDF of probability density function for the Gaussian random variable Gaussian distribution. Okay, Gaussian random variable or Gaussian distribution is fx of x 1 by sigma into root 2 pi e power minus x minus m whole square divided by 2 into sigma square. By the use of this, we are writing here fx of x 1 by 2 pi e power minus x square by 2. Okay, 1 by sigma is 1, and 1 by sigma into root 2 pi and e power minus x square by 2. Okay, sigma is 1. Fx of x, phi of x minus mu x by sigma x. Phi of x minus mu x sigma x. Here x is same as certain value of random variable, and mu x is nothing but mean of the random variable 0, and sigma x is the variance, which is sigma x is the standard deviation. Standard deviation is 1, variance is 1, then the root of variance gives standard deviation. Okay, square root of variance gives standard deviation. Square root of 1 gives 1. Therefore, phi of x, the probability cumulative distribution function fx of x, which is phi of x. Therefore, the probability of minus 0.505 less than z less than or equal to 1.456. This is the we have to find this value. What is the value of z? And fx, we are already proved that this is probability of x1 less than or equal to x2. We have capital F of x2 minus f of x1. Here we have f of x2. Here x2 is 1.456. Therefore, fx of x2 1.456 minus fx of minus 0.505, which is x1, first value and first lower limit. Okay, fx of 1.456, fx of x gives phi of x. Here phi of x, fx of gives phi of x. We already proved that phi of x, and minus fx of x1 is, which is also phi of x. Here x is minus 0.505. Therefore, phi of 1.456 minus 1 minus phi of 0.505. 1 minus, here minus is there. Complement of this one is 1 minus phi of 0.505. Therefore, phi of 1.456 plus minus 1 plus minus into minus plus phi of 0.505, which gives z table. We have by using this z table, we get the value. We get the value. Okay. Next, the random variable x. Random variable Now, probability mass function. What is the probability mass function for discrete random variable? Probability mass function. If x is a discrete random variable which takes the value x1, x2, x3, then probability mass function, which is this function fx of x, and the probability of x, which is equals to xi, which is nothing but pi. If x is equal to xi, I takes the value from 1, 2, 3, so on up to so on, and 0 if x, which is not equal to xi. If x is xi, then probability of x less than probability of x, which is equal to xi, but 0 if x not equal to xi otherwise. Okay, is called the probability mass function of random variable x. So probability of xi, which is greater than 0, and probability summation p of xi, which is equal to 1. The maximum probability is 1 and minimum is less than, greater than or equal to 0. Okay, we will see one example on this probability mass function. For example, tossing 3 coins, we get the sample space. We get the outcomes are tail, 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 head, tail, tail, and 8 possible outcomes. Here we get 8 possible outcomes if we toss 3 coins at a time. Then random variable 0, 1, 2, 3 takes the value, discrete random variable. The random variable takes the value 0, 1, 2, 3, which is number of probability of x less than, which is equals to 0. The probability which is equals to 0 means probability of here the random variable is number of hits. Here the random variable is number of hits. Number of hits. In the first outcome, the number of hits is 0. Therefore, the probability x is equal to 0. Probability of t means tail, tail, tail. Three coins are facing tail, which is equals to probability by 1 by 8. Probability is 1 by 8. Okay. If then number of heads, probability of x, number of heads is 0. Number of heads, probability of x1, x is equal to 1. Probability of x is equal to 1 means the random variable number of heads is 1. Heads are HTT. In this outcome, we are having one head, and in this also one head, and in this also one head, and in 3 outcomes we are having heads, one head at most. Most means one head exactly. Okay, probability of HTT and THT, TTH gives the number of probability, number of outcomes. Okay, here is 1, 2, 3, 3 by 8. The total number of outcomes are 8. Therefore, 3 by 8. Probability of x2, probability of x is equal to 2. Probability of x is equal to 2 in random variable x is number of hits. Here number of hits, random variable x, which is number of hits, is 2. Number of hits in this outcome, we are having number of hits is 2 and number of hits is 2, and here also we are having number of hits is 2. 2 coins facing at heads. Okay. Here also 3 outcomes are there. Having number of 2 heads. Okay. Then the probability of HT, comma HTH, comma THH, which is also nothing but 3 by 8. Okay. And the probability of x, which is equals to 3. Probability of random variable, which are the outcome having the 3 heads, 3 coins facing heads. Okay, the only one outcome is there, that is HHH. 3 coins are facing at head. The probability of HHH is 1 by 8. 1 by 8. Therefore, so summing these probabilities, 1 by 8, 3 by 8, and 1 by 8 gives 8 by 8. 8 by 8, which is equal to 1. Maximum probability is 1. Okay. Next further, the probability density function, or the PM probability mass function. Probability of x is equal to xi, which is xi. If x is xi, then the probability of x is equal to xi. 0, x is not equal to x. Okay. If x is equal to 0, x is equal to 0, which is x2 1 by 2, 1 by 8. Probability of x is equal to 1 is 3 by 8. Probability of x is equal to 2 is 3 by 8. Probability of x is equal to 3 is 1 by 8. Here x is 3 and x3, x2 is 2, x is 0. Otherwise, x is not equal to xi. X is not equal to xi, then this is 0. This is probability mass function. The cumulative distribution can be calculated as follows. Cumulative distribution function is sum of all these. We get cumulative distribution function fx of x, which is equal to probability of x is equal to 0. The number of heads here is 0. The probability value is 1 by 8 plus the probability of x is equal to 1. Only one head. We are having probability value is 3 by 8, and probability of x is equal to 2, which is also we are having 3 by 8, and probability of x is equal to 3 is 1 by 8. Therefore, the cumulative distribution function is 1. Understood? The probability mass function is 1. This. If we plot graph random variable versus the probability, the CDF versus PDF, probability density function versus cumulative distribution function, we get x naught is 1 by 8. 1 by 8, we are marking 1 by 8 here. In x1 means random variable x1 is the number of heads is 1. Outcomes having number of heads is 1. Here we are having 3 by 8. 3 by 8, 1 by 8 plus 3 by 8. Then x2 is number of heads are 2. Therefore, we are 3 outcomes. In 3 outcomes, we are having number of heads are 2, and we are plotting from 4 by 8 to 7 by 8. 4 by 8 to 7 by 8. Then x3, for x3, we are number of heads are 3. We are having only one outcome having all our heads. Therefore, the maximum probability is 1. By summing these probability values, we get the maximum probability value as 1. Okay. This is also figure. We are plotting CDF versus PDF. Plot CDF and PDF plot. Okay. Okay, x naught equals 1 by 8. X1 is 3 by 8. X2 is 3 by 8. X3 is 1 by 8. Plot graph. We are plotting CDF and PDF graph plotting. Okay. Cumulative distribution function for unit step function. This is now okay. Understood this problem, previous problem. Okay. Then the cumulative distribution function CDF for unit step function is given by fx of x pi into mu of x minus xi, where mu is unit step function, u is unit step function. Probability distribution function PDF for unit impulse function is given by fx of x, which is summation from 1 to n pi of tau into x minus xi. Probability of tau into x minus xi. Therefore, we'll see one problem on discrete random variable. The given data in the following table. These are the given data which are in the following table given in the problem, and the sub question is plot the PDF and CDF of the discrete random variable y, and write expression for fi of y, and fi of y means okay, using unit delta function and unit step function. Using unit delta and unit step function, write expression for fi of y and capital Fi of y. Solution is plot PDF and CDF. Here, first we have to plot CDF plot. Okay. Here CDF is the values are given in the problem itself. Okay. The y of k, yk is point value is 2.1, 0.21, 2.1 from 2.1. Fy of y is this, and here along the x-axis y of capital yk. Here fy of y. Okay, this versus this 2.1 versus 0.20. 2.1 0.21, and the 3.2 0.21, 3.2 0.21. Okay, 4.8 1.9, 4.8 from this one, 0.20 from first value we are plotting 2.1 to 0.20. Here this is 20, 0.20, this is 0, and from this we are plotting 0.21, 3.2 from 0.20 plus 0.21 gives 0.41, and for 4.8 we are plotting 0.19, I think so. 0.19, 0.4119 gives 0.60. This is 0, 0.60. For 5.4 we are plotting 0.14 gives 0.75, and 6.9 we are plotting 0.25. The maximum probability is 1. Okay, this is we are plotting the CDF. This is an easy process. Okay, next we have to plot PDF, probability density function. Plot 2.1 along with the x-axis we are having yx values, and along with the y values we are having fy of y values. Okay, PDF values. Okay, 2.1 gives 0.20, 3.2 0.21, and 4.8 0.19, and 5.4 0.14, and 6.9 we are having 0.26, 0.26. We get this, we are plotting x-axis as we are taking yk along with the x-axis, and p of yk along with the p of yk means py of k along with the y-axis. We are plotted CDF and PDF, and expression, right expression for fy of y and capital Fy of y by using unit step function and unit delta function. Fy of y, unit delta function is summation. We are already having this formula Fy of y, which is equal to summation I from 1 to n pi of delta into y minus yi, which is the pi is 0.20 delta into y minus yi is 2.1 plus 0.21 into delta into y minus 3.2 plus 0.19 into, here pi means, what is pi value? Pi is the yk values. Okay, yi means 2.1, pi is yk values, pi is p of yk values, pyk values, and yi is 2.1 yk value. Then plus 0.19 into delta into y minus yi means yk values 4.8 first, plus 0.14 delta into y minus 5.4 plus 0.26 into delta into y minus 6.9. Okay, this is the expression for fy using delta function. Here using the unit function fy of y, which is for summation I is from 1 to n. We are already having this formula in the first studying in this. Okay, pi into u of unit function by using a unit function y minus yi 0.20 u into y minus 21. Yi is the values in the table yk, and here 2.5 to 0.21 u into y minus 3.2 0.19 into u into y minus 48 plus 0.14 mu in u into y minus 5.4 plus 0.26 into u into y minus 69. This is the expression. We are writing expression by using unit delta function and unit delta function and unit step function. Unit delta function and unit step function. This is important problem which will appear in exam, I think exam, which is a problem from the model question paper. Okay, understood? Next class we will see expectations. Next class, in the next class, expectations. No, in expectations are next another problem. Okay, understood?